Welcome back to my channel, and this will be a news on the series of matrices and determinants. I would like you to hit the subscribe button for more videos. Now let's go back to matrices and determinants. But in this part, we're dealing with we're dealing on how to check for the condition for multiplication of two matrices. So when are you to multiply two matrices, and when are you not supposed to multiply two matrices? So the condition states that if A is a M by N matrix and B is a P by Q matrix, then AB is conformable when N is equals to P. So whenever N is equals to P, therefore you can multiply the matrices. And what does that mean? That also means the column of the first matrix must equal the row of the second matrix. Let me write it. So note, column number of columns in first matrix must equal number of rows in second matrix. That is what is called a conformable multiplication. So a multiplication is possible only when the number of columns in the first matrix is equal to the number of rows in the second matrix. So let's check it out. Number one, if A is equal to 2, 3, 1, and 4, and B is equals to 1, 1, and 1, one, 4, 1. Now, this A is a what? A is a 2 by 2 matrix. Wow! Because we have 2 rows and 2 columns. Why for the B? B is a what? 3 by 2 matrix. 1, 2, 3. 3 rows and 2 columns. So 3 by 2 matrix. Now I want to ask you, can we multiply these two matrices? Is it possible to find AB? Is it possible to find AB? Let's check it out. So how do you know whenever you have to multiply two matrices? How do you know whether it's conformable or not? I have a trick. The trick is this. You take the order of the matrix and order of the matrix times, so it will be 2 times 2 times 3 times 2. Can this cancel out? No. You can see these 2 and 3 are not equal. 2 is not equals to 3. Therefore, it's a what? Not conformable. So you can't multiply these two matrices because the number of columns in the first matrix is not equal to the number of rows in the second matrix. So that is not possible. So that is out. So you can't multiply these two matrices. So let's take out another example. Let's assume I have 1, 1, and okay, we have 2 columns here. 3, 5, 1, 7, 1, 9. Let's try it out. Let's check this out. This and this. How do you find? How do you check out if this is possible? So our A here is what? 3 by 2 matrix, because we have 3 columns, 3 rows, and 2 columns. While your B is what? Is 2 rows and 4 columns. So you have 3 times 2, 2 times 4. Let's check it out if it's possible. Is AB conformable? That is, AB is equals to 3 times 2 times 2 times 4. Now, you can see 2 is equals to what? 2. 2 cancels out 2. Since they are equal to each other, then that means you have a new matrix of what? Of 3 by 4 matches. Therefore, AB is conformable. And have order of 3 by 4 matches. So that will be the order of the new matches. So the new matches will be what? Will be 3 by 4. Let's take the last example. Is AB conformable? Is AB conformable? Let's check it out. So A is a what? Is 1 row and 3 columns. That is 1 by 3. Let's look at B. B is a what? B is 3 rows and 1 column. 3 by 1. So let's check it out if it's conformable. That will be what? A, B. And A will be 1 times 3 times 3 times 1. What happens? 3 cancel 3. You have what? You have 1 by 1. And that will be the what? That will be the order of matrix AB. So matrix AB will be what? Will be a matrix that has an order of 1 by 1. Now let's check this out if this is true. Let's multiply this and this, and you see you have a what? A 1 by 1 matrix, which is a single element matrix. So I'll do it somewhere here. That means I have AB is equals to 1, 1 and minus 1. Okay, I'll do it here. AB is equals to 1, 1 and minus 1 and 1, 3 and 4. This, you can see this single row multiply this single matrix. I've seen this single column. So 1, so that will be what? 1, 1 and minus 1 times 1, 3 and 4. 1 and 1 is 1. 1 and 3 is what? Is 3. And this is minus 4. And that gives us 0. You can see it gives us a what? A singleton matrix. Which is what? Which also means what? Also means a 1 by 1 matrix. You can see this confirms this. That when I multiply these two matrices, I have a what? I have a single answer, which is a what? A 1 by 1 matrix. A single answer. Whenever you have a matrix with a single element, it is called a singleton matrix. As one element. And you can see this is 0. You can see also what I did here also. When I cancel out the matches of 1 by 1. So you can see this method what tells you the new order of the matrix AB. I'll be doing the last example again. If A have order of 2 by 7 and B have order of 7 by 1000, find the order of AB. Solution. Order of AB will be equals to what? 2 times 7 times 7 times 1000. 7 cancel 7, you have what? 2 times 1000. So that will be the order of what? Of matrix AB. So you have to check for the order of a matrix. By cancelling out the row and column, you have this and this, and you have 2 by 1000. So let's do more examples on how to check the order of a new matrix when you multiply two sub matrices. So this will be a fifth example. Order of